Hi, my name is Pat Helland, and I'd like to talk to you about autonomous computing, which is some stuff I've been working on for many years and have a bunch of ideas I'd like to share. This is part one of the story. It's talking about the duality of personal information and shared information. Working across autonomous boundaries is personal to your partners and yet shares your resources. These are my own ideas and opinions. They are not necessarily reflective of the positions of my employers, past or present. Let's look at the agenda for today's presentation. We're going to introduce autonomous computing. We're going to talk about the three major pieces that go on inside of this pattern with fiefdoms, the autonomous boundary, collaborations, the sequences of messages that are related to each other to do some long-running work across boundaries, and then emissaries, which is code running outside of the autonomous boundary that helps you fill out the messages that you need to do work. Then we're going to talk about the types of data in this world. Now, there's private data contained inside the boundary. There's collaborations, or the messages going back and forth. There's reference data, which is useful information to allow you to customize those messages that are flowing back and forth with the autonomous fiefdom. And finally, there's user data running inside of that emissary, which is your helper from the outside. What does it mean to do work? We're going to talk about working across fiefdoms. What does it mean to do work across autonomous boundaries? How can cooperative work happen when two entities are independent or autonomous? And finally, we conclude by looking at the duality that's deep in this relationship. Each collaboration is personal, dealing with one partner. And yet, inside of this autonomous fiefdom, there are shared resources that you're using with lots of different partners. What is autonomous computing? So I first wrote about autonomous computing in 1999, and this is something that's been on my mind ever since. At first I talked about it inside Microsoft, but by 2001 and 2004 I was presenting it at multiple public conferences. Services, also known as fiefdoms in my discussions, are independent of outsiders. At the time, these were two-tier applications surrounding a database. And that notion became known as service-oriented architecture, and it soon emerged, I believe, from some of the things I talked about. Later, microservices emerged, and they're somewhat different and a lot the same. They don't focus on data as much, and so we're not going to talk about microservices in this presentation. The big idea behind autonomous computing is, let's assume autonomy. I'm different from you, I'm independent from you, and so I'm not going to really do some things with you like no transactions. I'm not going to do database transactions with an outsider. So if I have no transactions, the only thing I have is messaging. If I have messaging, that's going to run across space, across my work and across your work, and we're going to do stuff together. And placement across space will end up showing how we can do placement for scale. Now, messaging means it runs across time. You send a message and that happens, and then later on I send a message and back and forth. Now if it runs over time, there are business rules for uncertainty. You say you're going to do something and then you don't. So how do I cope with that? What do I think about that? So business rules for uncertainty help explain offline and reconciliation. Unfortunately, I did not publish a paper 20 years ago, but I have papers coming out now to make up for that. Autonomy is long distance, long running, and personal. Autonomy means I'm working with messages because shared transactions create dependence and risk, and so that is not autonomous. That's dependent, not independent. Long distance because messages happen across these boundaries. That's the whole point of the discussion is, what does it mean to work across independent and autonomous boundaries? And an example here is company A to company B. So it is in fact long distance work. Long running, it takes time to deliver a message. First of all, you do work to generate the message and commit that in your system, then it goes across and then it gets processed on the other system. So when you're doing this work, multiple messages are usually required. And these are related messages for each collaborative task. It's also personal. Each company may have many partners, but it's important to provide a facade that each partner is isolated from the other. If I go to a hotel, I don't really want to know about the other guests in general, and the hotel doesn't want to tell me about them. Autonomy is personal, shared, and scalable. Again, personal because related messages provide a sense of privacy to the partner. The pieces of work are dedicated to a specific partner. It's shared, though, because the business has resources, and those resources are being allocated and shared across many partners. And so you have pieces of work that are dedicated to managing those resources, and then how do you share them? It's connected, though, because pieces of work are connected with messages. Internally, you use pieces to connect those messages. And so you end up in this composition where messaging can connect pieces, and so the work can be comprised of many small pieces. There is a duality of autonomous work. It's both personal to each partner, but the resources are shared. And that's the first autonomous computing talk. It's also scalable because scalable autonomous work, you have many connected pieces of work, and the pieces can be moved around for scale. And that's the second autonomous computing talk. Now, these are combined in one version of the presentation that takes a little longer because the repeated material is not there. But again, there's two basic discussions here, the duality of autonomous work and how that can in fact be scalable. So let's talk about the three basic ideas in autonomous computing: fiefdoms, collaborations, and emissaries. So what are the pieces of the pattern? A fiefdom is autonomous computation and data, and it's autonomous or independent of outsiders. It doesn't do transactions across those boundaries. A collaboration is a set of related messages for one business task. So you're connecting these related messages because they're part of doing one piece of work, even though there's multiple messages associated with them. So this collaboration correlates the messages with a unique identifier. Now, emissaries help work with one or more fiefdoms, and they run outside the autonomous boundary. Usually they fill out the messages correctly, and that makes it easier for the fiefdom. This is centuries of business practices have followed this pattern. I'm not talking just about how computers do it. I'm talking about how our grandparents did it when all they had was paper to go across these boundaries. And this is just mirroring what they did. And this helps us explain long-running work, scalable systems, offline work, and more. So let's talk about fiefdoms and autonomous computing. What's a fiefdom? It's something that is independent and autonomous. Now, in English, that word was used commonly in the Middle Ages to describe a boundary of independence, a duchy, a barony, some kingdom. They were independent. They had their own customs, their laws, their way of working. It was just a place that things were different inside, and they had their own world. Now, because it's independent from outsiders, when you're doing work with a fiefdom, you can't just do anything. You can only do the things the fiefdom is expecting you to do. When I go up to my bank's ATM, I don't know what it's like for you, but all I can do is deposit, withdraw, transfer. There's only a handful of things that ATM will do working with me. Every time I try to get it to give me a JDBC connection to the back-end database, it won't give me one. It's kind of like I'm an outsider and I can't do work with that database. Well, that makes sense because you got to preserve the independence, and the bank needs to preserve its independence. So a fiefdom sets the rules for work, and that's pretty much how it's going to be. Now, there is private data inside the fiefdom. It's not shared with the outside. My bank doesn't even tell me much about the information about me, much less about others. And you can do transactions inside the fiefdom. That's common. That's how things work. But you never do transactions across the boundaries because across the boundaries, it's outsiders, and that's not autonomous. So what do? Well, you have collaborations for long-running work. What is a collaboration? It's a notion that I'm defining here as a part of this model, which is a set of related messages. Now, this is a pattern that's been used for centuries. Subsequent messages in the business operation would flow between business to business. In the past, it was with paper. And it does one long-running business operation. Now, when I was a kid, I remember these a lot, the multi-part, multi-page paper forms. And so there would be multiple pieces of paper that were attached to each other and different parts to fill out. And there was a serial number stamped in the upper corner. And you would walk in, and typically one party would fill out the part one and hand it over, and the back page would be handed back to you. And then the rest of the form would move on with more being written. Now that moved from department to department to accomplish the long-running work. So you did long-running work via multi-part forms, and as parts were filled out of the form, the back page would be taken off and kept inside of the department that was dealing with the work. Now these always had a unique serial number. That unique serial number correlated the pages and the work completion so that you could tie them back together as more and more work for the long-running operation would occur. Eventually, those completed forms were filed away, and then they were retired and archived. And there was a life cycle for the work, there was a life cycle for the paper forms, and it usually resulted in the paper forms eventually going to the shredder after many years. So let's talk more about multi-part paper forms. With a multi-part paper form, you had many writers on one form. Now, albeit one at a time, because they all wrote on the top page and then the back got taken off. So paper forms had many parts, many collaborators, but one writer at a time. So imagine you have a front desk for example, a car repair shop or something like that. Customer walks into the front desk. So the person behind the desk pulls out the paper form with many pages and many parts. Customer fills out the customer info in part one. The front desk fills out part two, describing the work that the company is going to do for them. The back page is torn off and handed to the customer so they could bring it back when the work is completed and they're going to make everything come about and get their car back or whatever it is. And then the next page is put in the file cabinet at the front desk. The other pages are put in the outbox. That outbox then takes it to the back office to do some more, and it comes out of their inbox to the back office where they do some work. And they fill out part three to describe the progress that's been made. The back page goes in their file cabinet. The rest goes into their outbox. And then the mailroom picks that up and moves it to the inbox of the executive suite, which is going to issue approval. And then the executive suite looks at the information with the customer info, front desk, back office, puts the approval, and puts in the last copy again in their file cabinet, and then pushes this to the outbox. And that would typically go back to the front desk, and the customer would come back in and things would get worked through to completion. Now let's come to a new concept, emissaries. Emissaries help you work with a fiefdom. Now they run outside of that autonomous boundary, so they're kind of outsiders, even though they're custom designed to understand the relationship, the protocol, the collaboration that's going on with the insider. So they help you work with the fiefdom, and they match the fiefdom's rules. And fiefdoms, they see the emissaries as outsiders, but they're pretty darn convenient. Let me give you some examples of emissaries. So when I first got my first house and tried to get a mortgage, and I was young and it was a crappy house and it was too expensive, we had to go to get a mortgage, and there was a mortgage broker who represented multiple banks, and they had information about interest rates and payment plans and different banks, and listened to our story and helped us pick which bank, and pulled forms out from under the desk, and we filled the forms out, and they got sent to the bank. Now, the bank didn't trust the mortgage broker. There was a credit check that they did trust that was done separately. There was a separate employment check. So they didn't trust the mortgage broker, but the mortgage broker was pretty darn convenient and made their forms filled out correct, and that was nice. Similarly, online shopping, before you do checkout, I view everything before submit as a form of an emissary. It's helping you prepare your shopping cart, your credit card information, all the stuff that the back end will need in order to fulfill your purchase from the online shopping company. So to me, that front part is an emissary, and it's all verified in the back end. Everything's checked after it's sent in. And then the third example is a mail client. The mail client actually is not trusted by the back end mail server, but it knows the protocols to see what's in your mailbox, to add things in your mailbox, to delete it, and so forth. So imagine you have mail server A, and you have your mail client on your phone. And the mail client, in my mind, is an emissary. It's helping make everything look pretty and understand what is going on in that mail server. But the only thing it knows is via the collaboration of messages going back and forth. Now, an emissary may represent multiple fiefdoms. As I mentioned earlier, mortgage brokers had many banks, and mail clients may have many servers. My phone can have multiple email accounts that it represents and unifies them into a very nice representation that combines them. And emissaries themselves may be replicated, and the replicas can track state of those ongoing collaborations. So I may have a mail client that is on my laptop. Now, indeed, my work email is on my work laptop and on my phone, but my personal stuff is on my phone or my personal laptop. So what they replicate and show me and combine it can be somewhat different if they're representing different fiefdoms. And indeed, that knowledge can be replicated and squirted across between these emissaries. Now, this is a pattern based on autonomy. Autonomy means boundaries and independence. Boundaries and independence mean no shared transactions. There is no way I'm going to lock up my database waiting for what you decide if you're an outsider. So I'm not going to take record locks. I'm not going to do transactions with you, but I will do messages and try to get work done to do business. No shared transactions mean a sequence of related messages. But that sequence of related messages, they need to be tied together. And I think we need a more formal notion of collaboration that makes it easy for the partners in each side of this to tie together those related messages. And again, the collaboration sometimes is annoying to fill it out, and it can be complicated. So having software that runs outside of the autonomous boundary to help you with the messages, the sequence of messages, that's a useful pattern we see in human life and also in computing life. Let's talk about the types of data we see in an autonomous world. Well, there's private data that's kept inside of that autonomous boundary of a fiefdom. There are collaborations, which are actually data, the messages and the sequence of messages that flow in and out of the boundary. There's reference data, which is information published from within the fiefdom that then can be used to help with the collaborations. And finally, there's user data, kept private to the emissary, running on the outside, but incredibly useful to implement the collaboration. Now, I differentiate between data on the outside versus data on the inside. And in 2005, I wrote a paper for the database conference CIDR, Conference on Innovative Database Research, and it talked about those differences. Now, inside data, that's pretty classic relational data. It's protected by a database and an application. And if it's relational, it uses values and it relates the values. And that's the relational model. There's no formal notion in the database of objects and identity. Furthermore, the shape and the form of the data is prescribed. You can change it as time goes on as you talk about what's in one table in rows and columns. Now, outside data is not quite the same. It ends up being objects with identity and maybe versions for those identities. Now, outside autonomous boundaries is where this stuff lives. It's outside the database, it's outside the application surrounding the database, and it's a thing that's pushed out into the mean, cruel world to be shared across boundaries. It's typically not protected by an application. And furthermore, when you wrote it, you wrote it. So what's in it meant what you meant when you wrote it. And so there's a notion of descriptive metadata. What was meant when it was created? Sometimes that metadata is contained inside the actual object that's outside, like in JSON or XML where you describe it inside. Sometimes it points to some description in some other fixed versioned metadata. Outside data is immutable. Once you say it, it can't be unsaid. Just like the president on TV. When you say it, people know it forever. Now, data flowing outside of a fiefdom is outside data. It is typically semi-structured, not relational. That's very common. It's objects with identity and maybe versions. It has descriptive metadata. The description of the shape and the form of the data happens at the time the data is written. And it may be self-describing, may point to another description, but it is describing, not prescribing the shape. And it is understood by the fiefdom and probably understood by outsiders because that's important if it's flowing back and forth between inside and outside. Now let's rethink data across autonomous boundaries. First of all, there is private data inside of the fiefdom, and it can be updated transactionally, and it's contained within that boundary. There's also reference data. Now that's used to fill out a collaboration, and it's typically sent from that fiefdom to the outside world. So let's do some examples here. A product catalog or a price list, the current mortgage rates for that mortgage broker, the shipping weights and the costs to ship a box from a shipping company. Those are all examples of information published, updated sometimes, but it talks about what it means to work with the autonomous company across this autonomous boundary. Next, there's single user data. Now that's owned by the emissary and owned to try to make the multi-message collaboration work successfully. Now, some examples might be a shopping cart. This is the stuff I want to buy, and so I'm putting it together and going to send it in on the collaboration. The user preferences, the session state. There are many examples of information kept outside the trust boundary that are used to help make it easier in interacting with the trust boundary. And then finally, the collaboration data. That's the messages sent within a collaboration. And again, a collaboration is a sequence of messages that flows across these boundaries. Now, the information in a collaboration may be derived from the reference data. So the product catalog information, the price list information, that would go into an order. It may be derived from other sources. So in that collaboration data, this, again, the sequence of messages to do work, you might have a customer ID, you might have a description of the items you want to buy, you might talk about the hotel location, room type, and dates. All of this information is going to flow across the boundary. Now let's talk a little bit about reference data. Reference data is really useful to fill out a collaboration to get work done. It might have part numbers and prices and delivery dates and shipping weights, all sorts of information that is useful to make it work. So let's take an example of a big online retailer, and it's got a back end, and the back end I view as a fiefdom. And it's publishing its product catalog and price list. And so that's information that talks about what can you buy, how does it work, what are the costs, what is the shipping date, when can it come. Now that shopping has got reference data and single user data. It's a combination of that published reference data and the information that you're accumulating on the outside as you're getting ready to talk to the retailer. So the shopping cart's an example. So the single user data is accumulated by extracting stuff from the product catalog and price list and adding other things like the user's credit card and so forth. And once you've accumulated all of that, you might do a checkout where the shopping cart is then converted into a collaboration message. So you fill out the collaboration with information from the shopping cart and you send it into the online retailer to make things get ordered. I think of this notion I call recurrent reference data. And so that's stuff that's published periodically. And so one example is when I was a kid, there was this thing called the Sears catalog. It was a very large book that came twice a year. It was a very common pattern. And it was a highlight of the year when we were children in the 1960s. It would come home to our home and we would sit around the kitchen table and mom would go through trying to decide, and we would all try to convince her to buy some toys that were in it, because this catalog, you could buy kitchen items, you could buy toys, you could buy clothing, you could buy tools for the garage. It was an amazing thing that you could do. And so we would all try to convince mom to buy from this Sears catalog. And so it's very common to see these things come out periodically. Nowadays, it's not every 6 months. Nowadays, it's updated every day or sometimes even more often. Nowadays, that reference data on an online environment is pushed out to caches that you read and look at when you're shopping on the computer. And it might be stored on literally tens of thousands of computers with all the products and all the multiple replicas of it to give information about those products and their prices and the other stuff. Now, a collaboration may cite the reference data's version. When we would fill out that catalog that came twice a year, there was literally a form in the catalog that we would tear out and would say, this is a form for the fall-winter catalog for Sears for this year. And so the form said how to interpret the reference data. Sometimes the fiefdom will take a particular price or something for a product and go and look and say, is that an acceptable price for right now? And the reason I say acceptable price is because prices go up and down, and you don't want to reject an order immediately. You typically want to, honor things for hours or days after the price changes. So the fiefdoms may accept stale reference data because this is not an atomic right now thing. It's got time and a lag of time that needs to be tolerated in order to make the business work. So the fiefdom either checks the versions or checks the fields, and it only accepts collaboration data that it wants to, that it thinks is within the bounds it wants to do business using. Online services, again, cache that reference data in server pools. And so you can see some really funny things. The replicas of a price are not updated constantly. They may be jittery. And as you're rolling out across replicas of the cache in an online system, there's a window of time when you might see the earlier price, the later price, the earlier price, and it settles down and it works its way through. And so consequently, the collaboration and the fiefdom will tolerate that variation as things are changing in the reference data. So again, let's rethink data across autonomous boundaries and recap this. What are the types of data in autonomous computing? Private data, inside the belly of the fiefdom. You don't share it directly with outsiders, only indirectly. Single user data runs outside of the autonomous boundary, but it helps you do the work with that fiefdom, helps you get those multiple messages across to do the business over time. Now, reference data is really useful because it talks about what the fiefdom can do, what things are, and it allows you to fill out those collaborations. And then finally, the collaboration data, that's the sequence of messages that flow across that boundary. So we see these 4 kinds of data. And you might have another emissary doing other work with different collaborations with the fiefdom. And you can also see offline emissaries. They queue their work. They queue the reference data that would come from the fiefdom is queued up and stored offline, and then they queue the collaboration messages that go back and forth. And indeed, from my perspective as a transaction person, because there's no shared transaction across the boundaries, pretty much all of these interactions are a form of offline because they do happen one step at a time with different messages and different transactions. So what's the data for autonomous work? There's private data used inside the autonomous fiefdom boundary. There's collaborations, which is the sequence of messages and the individual messages that describe the long-running work across boundaries. There's reference data. It has options that you can use within the collaboration that you're doing work with. And finally, there's user data, which runs outside, but it is the local goals of the outsider as it prepares the sequence of messages in the collaboration to get work done. Let's talk about working across fiefdoms. Here we have fiefdom A and fiefdom B. How do they get work done? So you do work without shared transactions. To me, when you say autonomy, you say independence, that means you don't share transactions because I'm not going to lock things up waiting for you. Autonomy means no distributed transactions. You can do local transactions, but not distributed ones. So work happens with messaging. You send and receive messages, and they're related to each other to do one long-running piece of work. And that's what I call a collaboration. Now let's dig deeper and let's talk about online shopping with collaborations. So I have an emissary that's going to help me do shopping. Now, in my model, when I go to a big e-commerce retailer and I'm looking at the products and putting them in the shopping cart and so forth, that online web experience or the experience on the app on my phone, that is an emissary. It's outside the trust boundary. Only when submit happens do things get prepared and go inside the trust boundary of the back end. So that emissary may have reference data, may have a shopping cart, it will push submit and create the collaboration. Now over there is the back end. The back end knows what's in the warehouses, what's going on trucks, how much money do we have, how much have we charged, it does credit check, it does all of the finances, all of the important parts it takes to actually do business as a part of that retailer. So in comes a message which says, let's buy this stuff. Pat wants to buy this stuff. And that means I want to reserve the inventory, I want to schedule a shipment, I want to check the credit card. And so all of that work happens in response to the new incoming collaboration. Now my email's kind of minding its own business here, and an email gets sent back to me when it usually comes within a few seconds and it says, bleep, your order is processed, delivery on Tuesday. I want to point out sometimes that message and that email can take 30 minutes or something if the back-end system is slow in its asynchronous queued processing. And that's a healthy, natural pattern to allow queuing on that back-end system. On Monday, the stuff is going to ship and I'm going to get my credit card charged. That's cool. So I get another email, which is stuff shipped, deliveries expected on Tuesday. Pretty cool. Also, that's wonderful. Now that back-end processing guy's, interacting with the shipper, doing his own things with the shipping company on the other side, but it finds out that the stuff arrived at my doorstep on Tuesday, so I get yet another email confirming the delivery, and that bleeps my email. Now that collaboration, number 75392, remains active. It'll remain active typically for 90 days to verify there's no problem, because I might call up and say, hey, I need to return this or something like that. So that ongoing sequence of messages may live for a while, but typically it will retire after an expiration window, which may be 30 or 90 days, depending upon the business rules for the fiefdom. Now, back when we had paper forms, you could do complicated workflows with paper forms, and you could manage subtasks with them also. And that would happen inside of a company or across companies. As I mentioned before, the online retailer might contact the distribution company, and that's a subtask to do my work to get my shipment to me. Or you might see, if I go to a car repair shop, that there's the car repair, but there's also the parts department that's dealing with it. So in this example, we're looking at Acme & Sons car repair. They're doing some work for Sally Smith in the town of Derriere. And then they use a new paper form to get the parts. So what you see here is you correlate these pieces of paper by putting the numbers, the sequence number for the form. And so those form IDs match it together. They correlate it together. So the car repair order, the parts order says, hey, what car repair order is this part for? And the parts order says the actual repair order, the repair order says the parts order. They're correlated with each other by looking at the sequence numbers that are present. You can do a complex workflow using paper forms. The subtasks can be managed with paper forms, lots of multiple steps, lots of related forms, and they're tied together with sequence numbers. So when the subtask completes, you can use the paper form to go to the other original major task, pull that form out and say the subtask is completed, tracking sub-subtasks and a very complex tree of work. This can be long running. In computers, it can be seconds, minutes, or hours. With paper forms, it was typically days, weeks, or months. And you would add entries to the multi-part paper forms with the subtasks informing bigger subtasks of progress. And you would append only to those paper forms, and that advanced the workflow. And so an example may be that I want to schedule my outgoing shipments to customers, but I got to wait to see when the incoming shipments are actually arriving. And then when they actually arrive, then I can use that to stimulate the actual delivery of the shipments to my customers once my suppliers get it to my warehouse. All of this can be driven by a complex relationship of paper forms. And that's how things were done before I was born, and I'm kind of old, so that was a long time ago. Collaborations, uncertainty, and reconciliation. Fiefdoms live in their own world. They are not tied to a transaction. But if I'm doing multiple things of ongoing work and I'm doing them across complex things, like suppliers of my parts, the customers buying my parts, I have a lot of uncertainty. Will this business operation complete? Will my suppliers deliver? Will my customers cancel? Everything I do in the beginning of a collaboration, it typically increases my uncertainty because I don't know if it's really going to happen. I don't know if I can make it all work. Now, reconciled work decreases uncertainty. When the airplane takes off, I actually know which passengers were seated on it, and so that closes off that uncertain business where I'm not quite sure which passengers will actually make it, not sure how my overbooking is going to be. There's a lot of things to worry about. So if I'm managing inventory for the widgets, for parts, there's a minimum that I may have in the warehouse, and there's a maximum I may have, and there's a probability distribution, which is, copes with the uncertainty of my suppliers delivering, my customers canceling, and I'm constantly living in a world of increasing and decreasing uncertainty. Collaborations mean uncertainty. Things increase uncertainty, and then later they resolve and decrease uncertainty. Can I sell more widgets? Will I have enough? Who will cancel? Will I get the deliveries? What's the risk versus the reward to making commitments with? That leads to notions of overbooking, over-provisioning, and apologies. Businesses have uncertainty. What I want to have is I want to have happy customers, so I could choose to not promise anything to a customer unless it's actually in my warehouse right now and I'm certain I can ship it from my warehouse. But that means I have a lot of inventory sitting there costing me money. So I might want to optimize that. I might want to promise to sell stuff even when I don't have it because I know some percentage will cancel. So I may want to overbook to limit my idle inventory. And I typically want to manage that middle ground between overbooking and overprovisioning to balance the business risk. Now, if I have pools of stuff that are equivalent, fungible stuff, that reduces my uncertainty. That is why hotels have a category of rooms. King-size non-smoking rooms, there may be 20 of them at the hotel, and so I can cope with uncertainty because they're equivalent. They're fungible. So I want to balance the cost and the benefit by considering, do I want lost business? Well, I'm going to over-provisioning will cause me to needlessly reject orders and I've lost business. Do I want to deal with angry customers? Well, overbooking may mean I need to apologize, and that's a drag too. So I wrote more about this in a 2009 paper called Building on Quicksand that was again at the CIDR conference. So what are the implications of autonomy across boundaries? Autonomy, well, that's independence. That means no shared transactions. No shared transactions means the only choice I have is sequences of messages and long-running work. Long-running work works across time, and I have to accept uncertainty. And accepting uncertainty means part of the problem is managing business risk. If I'm autonomous, I have to deal with uncertainty and risk and manage that risk. So now let's conclude by talking about the duality of personal and shared within autonomous computing. So first, let's talk about the duality of light. Light is both a wave and a particle. Light is a photon when it's running in isolation, when it's observed in isolation, and it behaves as a particle. But a collection of photons can behave as waves under some circumstances. There's the famous double slit experiment. If you have two slits and you only put the light through the left slit, you see a distribution pattern of the light that shows that it is behaving as a particle. Similarly, if you only use the right slit, it behaves as a particle. And so you see only particles when you go through one slit. However, if you put up two slits side by side and you put the light through two slits, they interact as waves. So they cancel each other when the troughs of the waves line up, and they reinforce when the troughs of the wave accentuate and reinforce each other. And so it's very clear that it's kind of unusual. Light is both a particle and a wave. Now, autonomous computing is both personal and shared. It's personal in that each collaborator sees a personal relationship, but it's shared because the fiefdom itself has to manage resources across many, many different collaborators. Personal collaborations are private or autonomous views of work. So I sometimes think of autonomy as bidirectional. You're independent across your various collaborators also. So hopefully there's no awareness of work by the other collaborators, and the impacts of sharing can be seen as transient side effects rather than actually something related to the single collaboration. Now, shared resources, they're private or autonomous to the fiefdom, and they manage the uncertainty of sharing. That becomes an internal business problem. How will I manage these shared resources and keep my customers, my collaborators happy? For further reading, I have a paper called Side Effects Front and Center in ACMQ in 2017 and also Communications of the ACM in 2017. So what are the takeaways of the duality of autonomy? Autonomous computing is a pattern of collaborative work across these boundaries. So we're doing work, but we have boundaries. It is long-running, long-distance, bidirectional, and personal. And you have personal partnerships, but shared resources. So there's pattern. The autonomous computing pattern has pieces to it. There's the collaboration, which is the sequence of related messages. There's the fiefdom, which is the boundary of independence, the boundary of autonomous work. Emissaries sit outside and help create the messages and the sequences to do collaborations. And then data patterns for collaborations, reference data, private data, and single user data are very important parts of the pattern. It's personal. Partners perceive a private relationship. The collaborations, the sequences of messages get work done for a single collaborator, and the other partners should not be seen. But it's shared because there's managed shared resources. So the goal is to mask the implications of sharing from these partners. And it is a duality because it is both personal and shared. The autonomous fiefdom has to manage the uncertainty that comes from living in both the personal and the shared world. So the duality of autonomous computing. Light is both a wave and a particle. Autonomous computing is both private and shared. Thank you for your attention to the topic of autonomous computing.